Welcome. Here we're going to talk about integration by substitution. So let's consider an example. If I would like to take the integral of 2x cubed plus 1 quantity raised to the fourth power times 6x squared dx. Now, up until this point, we have worked with integration with fairly simple functions. Here, it is technically possible to expand this 2x cubed plus 1 to the fourth power. We could do that and then distribute the 6x squared in. But it would be really cumbersome and make the problem really long. And so for U substitution, this is another integration method. And it's referred to often as U sub. And what we're looking for, we are seeking a function and its derivative within the integrand. So if I look here at my original example, the derivative of this internal component, this 2x cubed plus 1, the derivative of 2x cubed plus 1 is 6x squared. So I have a function and its derivative both within my integrand. And that is the key to being able to use U substitution for the following reason. What we do is we allow U to be some quantity. I'm going to call it this 2x cubed plus 1. It should be the thing that when you take the derivative, you get something else inside the integrand. So 2x cubed plus 1. du dx then will be 6x squared. And I actually end up solving for du. This relies on a little bit of hand waving about the way what du dx is, but I'm going to multiply that dx over, treating it kind of like a variable. If you get into higher level classes, that's not always exactly possible, so be aware that sometimes that's dangerous, but here we're allowed to do that. So I have this thing u, which is inside my derivative, my integrand. I have this thing 6x dx, which is also inside my integrand, and I can replace them. So I substitute those two things. So I end up with the integral of u to the fourth times du. It is important that we have to be able to eliminate both the dx as well as the other component. Not eliminate, but substitute for it. So that's why it is important that I have this 6x squared dx. I cannot take the integral if I have a mixture. So if after you do your substitution, you still have any x's left over, that is bad. That's not going to work. I have to successfully transform this over so that the only variable I have is u. Once I've done that, then I can take this integral. So the integral of u to the fourth, that's a simple application of the power rule. So this will be u to the fifth over 5 plus c. I have to add the plus c, of course, because this is an indefinite integral. I don't have number bounds on my integral. I'm not quite done because this doesn't really help me in terms of the problem. I had a problem that had x as the variable, so I need an answer that has x as the variable. So what I do then is I replace back my u with what I substituted as u. So I end up with a final answer of 2x cubed plus 1 to the fifth over 5 plus c. Now, we can always take the derivative in order to confirm that this is in fact the integral, right? Anytime you do an integration, then you can take the derivative to confirm that you did the right way, right? So if I take the derivative of this whole function, I need to apply the chain rule. So I end up with 5 2x cubed plus 1 to the 4th over 5. 5 divided by 5 is 1. C goes to 0 when I take the derivative because it's a constant. And then, oh, sorry, I need to do the derivative, the chain rule here. So I did the power rule on the outside. I need to apply the chain rule on the inside. The derivative of 2x cubed plus 1 is 6x squared. So I end up with 2x cubed plus 1 raised to the 4th power times 6x squared, which is what I started with in my original example. So this U substitution, we assign a variable to represent a more complex form. That more complex thing needs to have its own derivative somewhere in my integrand. I take the derivative of u and use that to replace my original function. So I'll use u as well as du. Then I have a much simpler function to take the integral of. And at the end of the problem, well, I still need an answer that is in my original variable. So I go back and I substitute back the original u, whatever I set u equal to get my final answer. Thank you so much for watching.